In these three examples, I'm going to show you how to set up a system of equations for a real-world application, but we're going to stop after we set up the system. We're not actually going to continue and solve. So what I just want to kind of go through with you is tips and tricks to writing the equation for your system. This question says, in one day, the Regal 17 Cinema Theater made $1,590 from 321 people that were admitted into the movies. Now the price for the adults is going to be $6 a ticket, and the price for the children's ticket is $4. So what we want to do is just write the system that will model our problem. So I'm going to define my variables first. I'm going to call C the number of children's tickets, and I'm going to call A the number of adult tickets. So one of my equations is going to have to represent the cost for those children's and adult tickets. So if a children's ticket is $4, that's $4 per children's tickets. And then if adults cost $6, so $6 per adult ticket, that will equal, if you charge $4 per child and $6 for an adult, that will equal $1,590. Now, I want to talk about how I knew to use this type of equation. Now, I kind of briefly said in a previous video, there are three forms of a line of an equation that we know, and one of them is called slope-intercept form. Now, in order to use slope-intercept form, you need to know slope and you need to know a starting point. And neither of the numbers that we were told, none of them represented what's called a rate of change, meaning like, like miles per hour or minutes, seconds per minute or something like that. And so in order to use slope in either of these two equations, slope-intercept form or point slope form, you need to know slope. And none of the numbers that we were told represented our slope. And so I knew that I had to use the only other kind of equation we have, which would be standard form. Now for my second equation, this one is actually just a little bit more simple. It's the number of children plus the number of adults. So children plus adults equal the total number of people that attended, and that was 321. And so those are the two equations for this scenario. Now the next two have to deal with just kind of numbers in general. It says JP is thinking of two numbers, but he won't tell you what they are. He tells you that the sum, the addition of those two numbers is 163, and the difference is 33. Write a system that will model your problem. So let's call X the first number, and let's call Y our second number. So if those are my two variables, here's going to be one of my equations. One number, the sum, so plus the other number. So the sum of the two numbers is 163. And then the difference of those two numbers, meaning subtraction, if you subtract those two numbers, you're going to get 33. And so then you'll figure out one number and then the other number. The addition of their two numbers is 163, and then the difference, meaning subtraction, is 33. All right, we have one more that we're just going to set up here, and it says Allison is 13 years younger than Nick. So I'm going to have my variable A represent the age of Allison, and capital N will represent the age of Nick. Okay, so Allison is 13 years younger than Nick. So Nick minus 13, because she's younger, that's going to be Allison's age. Nick subtract 13, you'll get Allison. Now the sum of their ages, meaning Nick plus Allison, is 118. So those would be the two equations for this scenario. Allison equals Nick minus 13 because she's younger, meaning less. And then the sum of their two ages here, when you add them together, is 118. I did define my variables, and these are my two equations of my system.